STA 3624 Time Series Analysis and Forecasting. Lesson 6 Autoregressive Moving Average Model ARMA Models. Before starting this lesson, I would like to recall the time series model we learned in lesson 3. So one of the models are moving average process of order Q, so we denote it as MAQ. So we can write that moving average model xt equals at subtraction theta 1 times at minus 1 subtraction theta 2 times at minus 2 up to theta q at minus q, where at is a white noise, right? And also we can write the autoregressive model of order P, and that is ARP equals xt equals phi 1 times xt minus 1 plus phi 2 times xt minus 2 plus up to phi p times xt minus p plus at, where at is a white noise. Here phi and theta are constants, right? Then invertibility. Their invertibility means there is an interesting duality between moving average process and AR process. When a moving average of order Q process can be written in terms of autoregressive representation, it is called invertible. If it means if moving average process is given, we can convert this into the autoregressive model. If we can convert this, we can call that is invertible, right? So now we consider how we can do this invertibility, right? So we now consider the moving average MA1 process, right? So we will consider MA1 process. MA1 process. Okay, we can write the equation as xt equals at minus theta 1 at minus 1, where at is a white noise with 0 and sigma w squared variance, right? Then now we can write xt equals, you know that the beta notations, I think b notations, you remember that, no? So if this is at minus 1, we can write that as b times at, no? If at minus 2, we can write this as b squared times at, right? We learn those things. Likewise a t minus q, we can write bq times at, right? By using that relation, so here we can write xt equals at minus here theta 1, instead of at minus 1 we can write b times at, right? Then xt we can write here, at is common term, so we can take at out from the brackets. Then here we can write 1 minus theta 1 b, no? Right. And we can subject at now. At equals xt over 1 minus theta 1 b. Okay, then I am writing this relation as this xt, or we can write in this way, right? We can take this out for the numerator, then what happen, it's come as the index is come as minus 1, it means that is inverse. So 1 minus theta 1 be inverse xt, right? There is another relation, right? So you know that these are the mathematical relations, right? So 1 minus x inverse we can expand 1 plus x squared plus x cube plus x to the power 4 plus up to infinity. So that is the expansion. That is a simple mathematics. By using that example, we can write at equals, this is like this way, x is equals to here theta 1b. So we can write 1 plus theta 1b, because first term is x, then second term is x squared. It means theta 1 b squared, no, then third term theta 1 b cube, next term theta 1 b to the power 4, up to infinity we can write, and here there is xt, right? Then we can remove the brackets, then at is come as this xt, because here 1, no, then theta 1 times b xt, right? And plus here square, no, theta 1 squared b squared, then he can take remove the brackets, then xt is there, then theta 1 cube b cube xt plus theta 1 to the power 4 b4 xt up to infinity. And now we can use this relation again. So here bxt bat equals at minus 1, it means bxt equals xt minus 1, right? So I can write xt is as it is plus theta 1 bxt means xt minus 1 plus theta 1 to the power 2 b squared xt, b squared at is at minus 2, it means xt minus 2 plus theta 1 to the power 3 xt minus 3, no, plus here theta 1 to the power 4 plus xt minus 4. Likewise you can write. Okay, now I can rearrange this. I am writing like this way at. First I am writing those things, and finally I am writing xt. It means theta 1 xt minus 1 plus theta 1 squared xt minus 2 plus theta 1 to the power 3 xt minus 3 plus theta 1 to the power 4 xt minus 4 plus up to infinity, plus last this one I taking writing here xt, right? So this is, what is this? This is we start from the moving average process, then it is converted into the autoregressive one, then it called, this is invertible, right? So that is how we can check the invertibility of this one, right? Here these things we did, and finally we can rearrange. Then this is a infinite process with AR with weights are theta 1 squared. It means we take a moving average one process, it is invertible for the autoregressive infinite, right? Degree is infinite, the moving average is 1. So that is how we can invert this processes, right? That is called invertibility, right? So now we will move to the introduction to ARMA model. So you know that, so we taking if for the moving average process we take order is q, for the autoregressive model order is p. Now here that ARMA is autoregressive moving average model, order is p, moving average process order is q, right? In the statistical analysis of time series, autoregressive moving average model ARMA provides a descriptive of a weakly stationary process in terms of two polynomials, one for the autoregression and second for moving averages. Given a time series of data xt, the ARMA model is a tool for understanding and predicting future values in this time series. The model consists of two parts, an autoregressive AR part and a moving average MA part. The model is usually referred to as ARMA PQ model, where P is the order of the autoregressive part and Q is the order of the moving average part. So if we take ARMA model P and Q, P is the autoregressive part with order P and Q is the moving average part of order Q. Autoregressive moving average process we can write in this way. So x of t we can write zt minus mu, where zt is white noise, and we can convert this into this form. This xt part is come to autoregressive model, and this part is come to AT parts. This the right handed side is come to moving average process with order Q, right? So and here we can take this is since these are the phi values, so I can write phi 1p, right? Those are constant into bxt. We can write y is that we can write this as b xt, no, right? This one b squared xt, right? This one bp xp, right? So we can write this as phi p b xt. Similarly we can do we can write this as using b operators. Then we can write that part as theta q b times at. Then we can subject xt, then it is coming as theta q b over phi p b times at, right? Here this one we can write this way, because we know that theta qb is this part, right? That is it part, or this part 1 plus b plus, that is right in here, and the other part also like same way. Okay, so then so when we are taking autoregressive ARMA model, moving average model, if we have PQ where phi PB, here phi PB equals 1, it means phi PB equals 1, it means it is converted to theta QB, it means that is a moving average process of order Q. And also if theta QB equals to 1, it is converted into the autoregressive model of order P, that is represented here, right? Then another thing we have to consider, so the stationary and the invertibility. So if we consider a moving autoregressive moving average model, we have to check the invertibility condition and the stationary condition. So those things are asked in the questions, right? So invertibility condition, any ARMA PQ process is invertible. So you know that what is invertibility. If it is invertible, this is the condition. Roots of the polynomial theta q b equals 0 lie outside the unit circle. Unit circle means r equals 1, it means radius equals 1 circle. So if it is outside of the circle, it means that is invertible. So what is this theta qb means? Moving average part. The moving average part equals 0. What happened? That that autoregressive model is invertible, right? We will see how we can find those things using an examples. So the next one is that stationary condition means for the stationary of ARMA PQ process, AR and MA model should satisfy the conditions of stationary process. That is, you know that what are the conditions to find a process is stationary or not, that is mean and covariance does not depend on time t, no. So root of the polynomial 5pb equals 0. Now if we find the stationary condition, we have to use the autoregressive part and we have to equal that part to the 0, and again that should be outside from the unit circle. It means modulus for the units should be greater than 1, right? So we will try to understand this using examples. First example is check for the stationary and invertibility. So the model is given xt subtraction 0.5 xt minus 1 plus 1.2 xt minus 2 equals at plus 0.7 at minus 1. We will consider how we can do this, right? Okay, so the given question is xt equals 0.5 xt minus 1 plus 1.2 xt minus 2 equals at plus 0.7 at minus 1. The first thing is, if the question is given like this, what you have to do is you have to convert, you have to write this in b operators. So how we can write xt minus means b times xt, no? If xt minus 2 means b squared times xt. Here how you can write this, b times at, right? So then we can write in the next step xt subtraction 0.5 times bxt plus 1.2 times b squared xt equals at plus 0.7 times bat, right? So then at and xt terms are common, so I can take xt out from the brackets, then it's come as 1 minus 0.5 b plus 1.2 b squared, and here at terms we can take out from the brackets, then 1 plus 0.7 b times at, right? Then we can consider the order here. What is the highest order of b? That is 2. Here 1, no, there is nothing, it means that is 1. And so you can see that here there is 2 parts. What is this? This is autoregressive part. So we can write this as phi, we can take autoregressive phi p bxt, no, this is autoregressive part. And what is this one? This is moving average part. We normally denote it in theta q b times at. So what is p is here, p is order, here p equals, here p equals order equals 2, and q equals, what is the order in here? It means therefore what is this? This is the ARMA model process with PQ. P means order of autoregressive part is 2 and 1. This is PR21 process, right? So the next thing is we have to check for stationary and seasonality. Sorry, stationary. So for stationary, what we have to do is, for stationary we have to equal the autoregressive part. Autoregressive part means this one, phi p b equals to 0. So what is phi pb here? This one. This is a quadratic equation, so I can write in this way, 1.2 plus b squared minus 0.5 b plus 1 equals 0. So then we can solve this one. So you can solve this using a calculator also, or you can use the equation. What is, if equation is given like this way, ax square plus bx plus c equals 0. So how we can find x? X equals minus b plus or minus square root b squared over 4ac divided by 2a. So you can use this equation, then you can find values of b equals two values we can take because this is quadratic equation. So b1 and b2 we can take, and so it is come as complex form. So that is 0.208 plus 0.8899 one solution. The other one is 0.208 minus 0.8899. So we can write directly b equals 0.208 plus or minus 0.889i. So this is a complex number. So here when we according to our condition, what is the condition for stationary? This one, we have to find the length. So but since then we have to find the absolute value of this length, no? So since this one is complex number, so you know that in mathematics how we can find if complex number is given, z equals x plus iy. So how you can find sorry, this is not modulus. If given that as z equals, this is the complex number, z equals x plus iy, so how we can find the mod z? That is modulus equals this part, x square root of square of x plus square of y. By using that we can find the absolute values of b. What is x in here? Square root of 0.208 squared plus 0.889 squared. So answer is come as, if you find the modulus of this, answer is come as 0.913, that is less than 1. So what is our condition is, so it if it is in stationary, root lie outside the circle. So this is 0.9, and that is less than 1. It means therefore what can you say, the given process is non-stationary. Given process is non-stationary. Why is that? Because that is inside the unit circle. If it is stationary, according to the theory it should be outside the unit circle. Okay, so then next one is, so we have to check for the invertibility. For invertibility, so what is condition for invertibility? Theta cube, it means the moving average part should be equal to 0, then that also lie outside the unit circle. So we will consider now this part, that is 1 plus 0.7b, that is equal to 0, then b equals minus 1 over 0.7. If you simplify this, you can take minus 1.428, but we need absolute value of b. It means we absolute value was 1.428, that is 1.428. we didn't consider minus value, all are positive when we are taking the absolute values. So what can you say, that is greater than 1? It means that is lie outside the circle according to this theorem, that is roots, that's modulus of roots greater than 1. So what you can write is, then this is so we can write therefore the given process is invertible, right? So we check stationary and invertibility here, that the given process is non-stationary but it is invertible.